comment here. But he is actually the proud father of a new child as of yesterday morning. So he is not here. However, we have in his place a very exceptional speaker. He's the co-founder and chief product officer of Cloudant. He's got a PhD in physics at MIT and spent 5 years analyzing data from the relativistic heavy ion collider. You want to explain that?
It's right here in the state of New York. It's on Long Island.
It's in Long Island.
It's Brookhaven National Lab.
Wow. Okay. He seems to know what it is. I don't know. In any case, please welcome. We give a great round of applause for Alan Hoffman.
So, thank you for the introduction. Thank you everybody for coming. It's quite the turnout. So I hope that this is informative. My talk is about winning big data applications in Cloudant NoSQL. Winning being an adjective, not a verb. So not or a hashtag, or not like winning, but about successful big data applications and what it takes to build successful big data applications on Cloudant NoSQL. I'm going to focus mostly on the big part of the big data applications because at Cloudant and for many of our customers and many more applications around the world, it gets challenging when you get to a certain scale. And that scale can be in data volume, which is a fairly common scale problem that we run into. It can also be in terms of users, in terms of current connections. It can be in terms of global scale. So getting users all around the world, making sure that you can service those users in a low latency fashion. So the kind of governing theory around the talk is that you guys want to build big data applications. How many people here are engineers, like core developers? And how many people are like product managers, people that own product, people that own a couple people? What else? CEOs, founders? How many people? Awesome. That's great. So all of you are going to be wildly successful, and when you are, you're going to have applications that are going to run into scale problems. And hopefully, I'm going to share some of the lessons that we've learned, not only building Cloudant, but lessons from our customers on that front. As Eric pointed out, the late programming note, my co-founder is had his third child. He wanted to be here, but he sent me instead. So that means that it's going to be a slightly less technical talk because Adam is our CTO and he get more into the weeds. Mine's going to be more around kind of product issues, but I would be more than happy to pass on any questions to him to answer anything afterward. If you want to get really deep in the weeds, Bobby is just as technically knowledgeable as basically anybody in the company, so he can answer your questions as well. And then Christine here is another, she's our marketing coordinator, and feel free to bug her as well. Okay, so let's jump in. So this is me. I'm the Chief Product Officer. I was there at the beginning of the company, which gives me a little bit of credibility or respect or something. But I started my career as an academic physicist working on very large data problems. So Large Hadron Collider, CMS. So me and my co-founders were working on these problems. So this machine here, this is one of the ones that my co-founder Mike worked on, pumps out 1 petabyte a second, 24 hours a day, 365 days a year when it's on. 1 petabyte a second. That data has to be analyzed online, has to be distributed to first level of triggers, first level of cuts, has to be, some portion of it has to be stored at disk, and then that data has to be distributed all around the world where tens of thousands of scientists from 100 institutions around the globe want to access it, want to do things with it. These are scientists and scientific data, it's physics data about collisions, but you can think of it as any type of data, right? So you're building an application, you have a global user base. It doesn't really matter what it is. All you care about is that there are tens of thousands, or even more. I mean, in the case of the web applications, you're talking about sometimes millions, tens of millions of people want to access all this data around the world. It's a pretty challenging problem. This is kind of where we, as the founders, cut our teeth, was problems in distributed data. In this type of physics, experimental particle physics, you do a lot of computer science, you do a lot of database management, you do a lot of kind of bookkeeping. And that's where we took this idea and we said, well, we're pretty good at this, and we've got a background in it. And we saw the trend in the world of the web and mobile saw in big physics, big science, were becoming commonplace in big data applications on the web. And it was clear that it was going to become commonplace on small applications on the web. Right? Everybody was going to have this problem. At the time, this was right around 2007, 2008, Google and Amazon had published a couple seminal papers. The original MapReduce paper, the Dynamo paper. These were kind of our inspiration for, we looked at those and said, okay, these companies are dealing with this problem right now. They have to do it a special way. Current technology isn't working for them. They have to do it a special way. We can take some of our expertise and we can actually make that into a market solution that we would hope would provide that sort of value. Let me see if I have any other notes. So we saw the opportunity. We had a bunch of friends in product development, so we kind of took it and ran. So this is what we do. We're a distributed database as a service. We manage your data so you don't have to. I'm going to try not to make this too pitchy. Let me know. And also, I come from the kind of a academic background, and this goes a lot better if people interact. If you ask questions, jump in, feel free. It's not going to be as fun if I'm just up here lecturing. We are aimed at developers, engineers who are looking for high-velocity applications, high-velocity development, right? Iterate quick, iterate fast, and forget about the drudgery and the table stakes of getting your database online. We've got about 13,000 customers, and it was founded by me and a couple of my colleagues who are all in grad school together, decided that we didn't want to deal with the crap of academia. No offense to anybody in academia. This is just all I said, only with pictures of our customers, so we can move on. So, how to build a good data application. So as the product owner of the company, so I spent the first 3.5 years as CEO. I've since moved into product. I talked to a lot of our customers. I spent a lot of time figuring out what they need. And in that role, we've come across a number of patterns and anti-patterns for building large-scale web and mobile applications that basically cut across verticals, right? So, you see this in terms of consumer apps, obviously, enterprise, pharma, research. It really doesn't matter, because at the end of the day, you're talking about a lot of data, you're talking about a lot of users accessing the data, and you're talking about putting it around the globe. And those sorts of patterns aren't specific to one particular vertical. They really are horizontal. And so the kind of purpose of this talk is to take some of the lessons that we've learned from our users and hopefully share them with you guys so you can take them home and not make some of the mistakes that both we and they have made in the past. All the themes that I'm going to talk about in the next few slides, they all emerge from real customer problems, real customer needs, things that we work through with them, and things that we work through for ourselves. So it's not, I hope it's not a bunch of, I think it's just a bunch of made up talking points. So, if there's one thing that I'd like you to take away from this talk, it's that this quote is something that you do not want to do. Is anybody here a poker player? I'm a poker player, and there's this maxim in poker that the very first thing, before you do anything, plan your hand, right? That's the whole, you want to plan what you're going to do in the hand. Building an application is a little bit, it is similar, right? If you don't go with a plan, you say, well, your boy scaling is a great problem. We'll deal with that when we have that problem. Not only are you definitely going to run into that problem, but that problem could sink you, right? A little bit of forethought, a little bit of planning ahead of time can save you time, money, frustration, employees. It can save you a lot of hassle. Just make sure you plan your hand. So, that's rule number one. That's the, if nothing else, remember, plan your hand, and hopefully that will help. Rule number two is start building something, right? Never underestimate the inertia and the problem it takes to getting things off the ground, right? So these are a little bit of odds, right? You want to plan, but you want to overplan. You want to build, you want to start building immediately. And while you're building, you want to make sure that you have your eye on the future, that you're looking towards scale. I don't think anybody here would start with the goal of building a small app. And maybe you would. Maybe there's like really niche things that you want, a few hundred users, and now you're good. But I think that most developers we talk to, most developers that are going to start out in the world, they want to build something huge, something big, something that's going to change people's lives. You're not going to change people's lives if you can't manage the scale. You will run into, you'll be part of the graveyard. So a few patterns. There's an emerging kind of set of standards in web and mobile application. Don't reinvent the wheel, right? There's a reason why HTTP has basically been the language of the web for as long as it's existed, right? It works. Use it. JSON is becoming, if not already, is the de facto data transport, data encapsulation technology, right? Just use it. It works. And then RESTful, I'm a little bit less sure about this one because before that we had SOAP and we had a whole bunch of different ways of accessing data. But it really seems like we've come to this place where everybody's condensed on REST as the way to really interact with data. It's the API to your service, right? So these are the technologies that we want to use. These are the ones that are proven. They will scale and they'll work. If you try and reinvent the wheel, best of luck to you. So this is just a nice kind of example of how you create a document just from, basically from your browser, right? That's one of the great things about these technologies is they are the lingua franca of the web, so browsers speak them. There's client libraries, there's a whole ecosystem around this technology. So just use it, it works. Another thing would be search. I would argue that anybody that has a data problem has a search problem. Right? There's no, you can index and you can distribute and you can do things with your data, but ultimately you want to find stuff, right? And you want your users to be able to find stuff. So, using search, I would argue, a well-documented, well-used, well-oiled machine like a Lucene search engine is the way to go. So, this is a way to create a secondary index on your documents and then how you can query it using just simple URL structure with some query string parameters. And humans would be billions times better. We have customers that do this, and we're not the only ones. Customers run their own Lucene instances. Customers use Elasticsearch. There's a lot of different tools out there. But like I said, if you're building an application and you're not thinking about search, you're probably going to use it, unless it's like really specified, something esoteric. So next, so it's not enough to just get it off the ground. It's not enough to just grow. You got to make it fast. Speed is becoming more and more important. In science, we have this saying that milliseconds are valuable things, and seconds are infinity, right? Oh, if something takes 10 seconds, that's forever. That might as well take an hour. Might as well take a year. You have so little time to convince your user that what you're doing is valuable, and every millisecond that you waste is going to drive some of them away. Now, there are ways to deal with this, and there are great technologies to make things faster. There's caching, there's a lot of in-memory stuff. But one thing you're not going to be able to do is go faster than the speed of light. Right? Speed of light from here in New York to San Francisco is 35, 40 milliseconds, something like that. You got to go back and forth. That's 90 milliseconds. You got to do it a couple times for each request. Now you're talking a couple hundred milliseconds. All of a sudden you have like half a second. Just if you want to, if your data lives in San Francisco, somebody's here in New York using your application, that's already like half of infinity, right? So one of the patterns that we've seen in a number of our users that have found success is putting their data in multiple places, right? So this is a nice, marketing map of all the places where we have data centers. And there's probably a couple more that have been added in there. But the idea is that you want to put your data, your application, where your users are. So you have a community here in New York. Great, you should have data. You have a community in Southeast Asia. Great. They shouldn't have to pay the penalty of accessing the data wherever the cheapest hosting is. You have to put your data close to them or risk losing their attention to someone else. Right? Milliseconds are very precious. So make sure that when you are building your applications, you're thinking about where your users live, and how they're going to access your data. Right? If they're going to do things there are applications you can build that you don't need to be interactive. You can download things and have an offline experience if you're building some sort of desktop game. But for interactive web applications, mobile applications, you really have to think about the milliseconds because you only have so many of them. So, as I said, talked to a lot of customers. We see a lot of patterns and anti-patterns emerging. These are kind of 5 tactics that I'm going to go through. I'm going to go through each one individually, so you don't have to memorize them or write them down. The first two are actually 2 sides of the same coin, and we'll talk about that. And then, building stateless middle tier, planning on failure is vitally important, and then having a mobile strategy. So let's jump in. Okay. So avoid contention to update a particular piece of data. So you have a database, you have your data living somewhere. You have people wanting to access that, right? If you try to store as much as possible in one record, be it a document or a row in a SQL table or an object in your programming language, if you try to store too much, you're going to end up with contention over that piece of data. You're going to end up with multiple people trying to write to it. That's going to cause problems in systems with locks. That's going to cause problems because we're not going to be able to access the data fast enough. In systems that are, have multi-version concurrency control, you're going to have to deal with conflicts when you have multiple users making different writes to the same document. These are things that you need to think about as an application developer. How you want to structure and model your data. So I think the takeaway is that it's better to encapsulate a small amount of data in your tray, right? So minimize what you need, and then use something like a Lucene, use something like MapReduce, use something like stored procedures to build indices on that data, to do the aggregation not in the main data itself, but on an index system. It allows for fast query, right? So you've taken a problem of a lot of data contention on the right side, and you've actually turned it into a problem that's much more easily scalable by making it into a read problem, right? By spreading it out and having and querying the indexes instead of trying to all write the same time. So be careful about data contention. There's a nice blog post about this from one of the CouchDB committers, Stephen Lenz. If you can check it out, you can show the slides will be available and you can check it out. But it kind of gives you a flavor of this, right? It's like how to do quote-unquote joins in a document database. This doesn't have to be CouchDB or Cloudant, it could be any one of the NoSQL databases out there. But the idea of making it encapsulated, making your data small, and then using indices and sort of procedures to do all the aggregation on the fly. That will help as you scale. Second pattern, so I'm going to say this is exactly the opposite. It kind of is. And that's the data locality patterns, right? So if you read Amazon's DynamoDB grid, or if you go to their DynamoDB website, they'll tell you if you want a very nice, smooth hash space, you want to spread it out over all these nodes in a very even fashion, you need to avoid hotspots, and you do. And that can be challenging. But don't let it gate you, right? Don't let that be the driving force in application. So when you make a document request, in a database like Cloud, you make a document request, everything's nice and localized, right? You have the boundaries of a transaction, the boundaries of an atomic change to the data is all in a single document, right? So you don't have to worry about grabbing a piece from here, a piece from this table, and smashing it together. So it's really nice. It prevents kind of hotspots. It allows you to spread the work over more and more nodes, right? You don't have to worry about a single write master. But of course, if you're doing what I said in the last slide, and you're using MapReduce, you're using Lucene to build indices, this no longer holds, right? Because now you have to actually go out and query all of the different nodes. When you're talking about a single document, right? Single document read, in most Dynamo-like systems, you're going to make a request. Consistent hashing algorithm is going to tell you where that piece of data lives. You're going to make that request to a single node, or in our case, 3 nodes, and get the data back as fast as possible. You make a queue request. Now you're talking about reaching out to all of the different nodes in the system. And for those of you who don't know what Dynamo is or scalable data systems, so this is a way of making horizontally scalable data applications. It basically uses an algorithm that tells you, based on some property of the document, be that a hash of the ID or some sort of range, some sort of timestamp, where that document lives in your servers. Right? I guess it goes without saying that using that the scale up world is kind of gone. Right? We're in a scale out, in a horizontally scalable world. You don't want to keep buying bigger and bigger servers for your database. You want to buy more and more small servers. This is what Amazon does. This is what Google does. These were the pioneers of big data systems, and this is what they do. This is what you should be doing when you're thinking about building your app. So, these are two sides of the same coin, and how do you make a decision? Well, it kind of comes down to your application and where you're going to anticipate the bottlenecks are. Basically, it's where you expect the load to come from. Are you building a write-heavy application? Are you building an application that is going to, that you're going to write once and then millions of people are going to read individually? That should inform your decision about what strategy to take. How much data to keep into a single record, and how much should you rely on indices? If you have a write-heavy application, something where reads are very rare or relatively rare in comparison to the number of writes that are needed. And if your latency requirements are not too stringent on those writes, having lots of smaller individual documents, doing the aggregation thing, basically point number one, that's the way to go, right? You minimize contention, you minimize hotspots, and you allow your application to scale. If you have a read-heavy If you have a read-heavy application, it's better to use some sort of offline process and then put that, take the results of your aggregation, your calculations, your search, and put that into an individual document. If you have a read-heavy application, you don't have to worry too much about contention for data. You have to worry more about having to data localization. Right? You have to worry more that you don't want to make queries to all of your system. You want to make queries to specifically where the data lives in that case, right? So, do a little bit of thinking up front. Kind of goes back to point number one, plan your hand. Know where the bottlenecks are going to be in your system. Anticipate those bottlenecks and design your system accordingly. So those are kind of two aspects of how you want to model your data. And I'm happy to, data modeling is kind of where we all grew up, and happy to talk to people if they have questions afterward and shoot me an email. But that's one of the things that I think that we're passionate about is like modeling your data, storing it correctly. So pattern number 3, use a stateless middle tier. And this is becoming more obvious, I think, but there's still a lot of applications there that use out there that rely on things like sticky sessions, right? That makes it very hard to scale elastically in your application. It's not really easy, but it's more easy to make your application layer stateless than it is to deal with the fallout if it's not, right? Make it something that can scale really quickly, really horizontally using cloud services. This is the bread and butter for a service like EC2, right? This is what it was built for. Just do it, right? You make your application service lightweight, make it stateless, and then as you grow, as your number of users, gets bigger and bigger, you just turn more on, right? Your application shouldn't have to remember anything about the users, right? You should be able to just make requests to it and have those pass along to the data layer. And if you have to use it, if you have to make that sort of determination and you have to have that sort of record keeping in the data layer, that's fine. Your data layer is going to be stateful anyway. You can't get around it. So there's different strategies for scaling that. Scaling your application layer should not, you're inviting trouble by having those sorts of sticky sessions. It's much, much too much work in that. So let's do a couple other things. Don't create your own problems in the apps here, right? Don't shoot yourself in the foot. Don't shoot yourself in the foot. Penfold, and this is the one that I feel closest to and I would like to talk the most about. So plan for failure, know how to recover. I don't know if anybody else is a Princess Bride fan, but the masked man says life is pain, and anybody who tells you differently is selling something. Well, I mean, basically anybody who's telling you anything is selling something, but he's right about the life is pain. Everything is going to break. Everything that you build, everything that you rely on, all of your infrastructure is going to break. Don't believe anybody who tells you anything different. And plan for when that happens. There's a lot of really good strategies out there for planning for this stuff. Take some time, plan your hand, and make sure it works. So, on the list of things that have broken, we've been around for 5 years. I don't know if any of you remember April 2010 when EBS blew up all of Amazon and took down the internet. That was fun. Individual disks fail all the time. Mean time to failure is not as long as you think, especially in big systems, right? Know what you're going to do. RAID cards, networks, you're going to get net splits in between your servers. These things are just going to happen, and you need to be ready for them. I can talk a little bit about how we do it. In Cloudant, we do redundant, multiple copies of every piece of data in the system by default, and we actually don't let our users change that. They say, "Oh no, I don't need that much storage. I'm only have one copy of data." We say, "No, you're not, because I can guarantee you that 3 months from now, when that node goes down, we have to make a replacement. You don't want that data gone. You need that data." So we have multiple copies of data at any one time. We have in situ snapshotting. So in case of corruption, in case of data corruption, you can always roll back to a previous version, right? And I'm not talking about just machine corruption. I'm talking about malicious user corruption, right? When people talk about data security, one of our advisors at board members, going to be Hoffman, talks about a big pharma company really into data security. No, we can't put our data anywhere else. We have to have it all in house. We have to do it all our way. Otherwise, it's secure. Somebody walked into the data center with a thumb drive, stuck it in the computer, got away with it, right? In the same way, you have, I say it, disgruntled ex-employees. You have engineers with fat fingers. You have idiots like me trying to make changes in code, and you can corrupt your data pretty easily. Know how to recover. And in Cloudant, we do that using a number of strategies, but the primary would be in situ snapshot. And then have backups. That's basically the ground level, right? Make sure your data is backed up. Make sure your data is backed up offsite. Make sure your data is backed up in a different data set. In Cloudant, we by default, for our multi-tenant clusters, we run actually split clusters in 2 different geographies. So when I say we have multiple copies of the data, 2 of them are going to be in the primary data center, one of them is going to be in the third, and they are all live and can all be queried. We have literally had incidents where entire data centers have gone offline for, luckily not days at a time, but hours at a time. And our users had to rely on the quote-unquote backup copy. Right? Make your backup copies warm backups, have primary data, have warm backups, have cold backups, and then have deep stick storage. Your users and your customers and your engineers will thank you for it when things go wrong, and they will. This is what we like to say. We like to, for those of you who have the Sleep More t-shirts, right? This is where that kind of saying came from. We like to let our customers sleep. They sleep better at night knowing that we're watching out for their data and that there's backup strategies in place.
Do you guys sleep?
What?
Do you guys sleep?
A little bit more than we used to, but not as much as I'd like. Yes?
How is the data, how do you implement the data security in your pipeline? Multiple data centers. What is the strategy that you have a strategy?
So data security, you mean on the wire?
Can you repeat the question?
Yeah. So the question is, how do you implement data security in transport? It's a great question. So we, obviously use the same sort of encryption strategies that typical banking does. We also actually use only private network for our data centers, right? So we're not really relying on public internet. We have with our partnerships with our providers, we get the internal network with the fiber and the pipe between the two. That helps a little bit. You're not going to have people listening in, quote unquote. But it's a good question. It's something it's a difficult problem. You can do encryption on disk. You can do encryption over the wire, but what you can't do is you can't encrypt data when it's being read by one of the applications unless you have a pretty sophisticated system. So
does that slow that down a lot, or
what? So yes, if you need to have on-disk encryption, that's going to slow down your application. Because every time you read a piece of data, you're going to have to key, you're going to have to decrypt it, you're going to have to send it to, and that's not just sending it to users, right? That's sending it to processes, to your mappers, your aggregators, your indexers. So yeah, there's going to be performance there. The customers that need that are willing to pay that performance fee because it's very important for them. There's compliance reasons in some cases. We're talking about HIPAA, government, and they have very strict rules that they have to adhere to. The majority of our customers actually don't need that. They need things like passwords to be encrypted, but they don't need the everyday data. You're talking about consumer applications where it's, even if it's like Game Fitness for one, right? Like their main data is, workout plans, right? Well, somebody goes in and sees a couple workout plans. It's not really a big deal. They're not even personalized, right? It's just data about how you work out, videos for proper treatments and such. So the majority of our customers don't need that, but for the ones that do, they have to know up front that they're willing to pay a penalty.
Alan?
Yes, sir.
So I think the question is not from the application to the database itself. Between the data centers, do you do something special because you said you have multiple, like 8 data centers?
Yep.
So between them, do you have some kind of security that you have set up, or are you relying only on your partners?
We rely on our partners for a lot of that. Like I said, the internal network, and then relying on kind of the various providers to make sure that their internal network is secure.
Because it becomes more risky when you have multi-master database, right? So
Absolutely.
That's why.
So to add to that question too, excuse me, I'm fighting allergies all week, but we have, with cloud, you get kind of this boutique experience, right? So sometimes you think about the data centers that we have and what we actually offer, but you actually get to work with guys like Alan, technical account manager. So it's also very company specific, and it's also very application specific. So you're not putting data in somewhere and it's going through random data centers you don't have visibility into. We really work hard with our prospects and our customers to figure out what's important to them. So the reason that we partner with Joint, the reason that we partner with Rackspace, Software, and other providers, well, they all do a pretty good job. They all offer different bits of functionality or feature set that really helps our customers. So a different profile of customer might leverage Joint, a different one might leverage Software or Rackspace, depending on compliance, depending on relationships, depending on different intricacies of these networks. So the security is a bit more at a specific level. It's not just flying to different data centers. You as a customer can choose where they live. You're not going to hit every 8 data centers. You're going to be like, I have presence in Europe and I have a presence in the West Coast, and maybe those are your 2 primary data centers. Maybe there are 2 in the US. So it's very customizable to the application of the customer as well.
Thank you. Actually, somebody might open up a window. I don't know if anybody else is warm, but it's pretty warm up here. So pattern 5, this is something we've seen over and over, is that you want to have a mobile strategy on day 1. You've all, I'm sure, seen the statistics about the growth of the mobile web, how much it's going to overtake the web. It's already overtaking the web. I'm not going to put those up there. The one that I saw recently that I really thought was interesting is something like, it's like 90% of mobile searches lead to an action within 4 hours, whereas 90% of web searches lead to an action within 4 months. So if you don't have a mobile strategy on day 1, you're already behind, right? You're already getting behind. And personally, this is just my own personal thought, is I don't think that HTML5 is the answer yet. Right? I think that the users, when we surveyed our users, our mobile developers, they found that the vast majority of them want a native app. They want a native iPhone app, they want a native Android app. Using kind of the cross-platform things can get you so far, but it's not the same. And your users can tell.
I have a question. What if you're more concerned about airplanes? then like the mobile, how important is that? Say your big client.
I would argue that it might not be as important today, but it's going to be super important in the future. I mean, you're seeing more and more enterprises that are building applications that are going to run on a tablet, going to run on a phone, right? You have
Say like a big pharma. How would a big pharma?
big pharma might not be the best example because a lot of their data is either genome or protein or something like that. They might build something like a viewer, but to feed the data to the tablet. But imagine retail, Salesforce. These are all big enterprises that are going to be giving applications not to their users but to their employees, right? Healthcare, you're already seeing even HIPAA-compliant applications that live on the iPad so that the healthcare provider can walk around, have access to all the information at their fingertips. It's not just a consumer world in mobile applications. It's not there yet, but like 5 years ago, we're probably where we were 5 years ago. It's coming.
What about defense?
Defense is I think defense is even further ahead of the curve, to be honest. I've talked to, these are not our customers, and I can't talk about our customers in the defense world, but I've talked to other companies in the defense world that, the thing that they need most of all is mobile computing, right? Imagine you're in a hostile environment. You're in an environment where the wide area network is completely untrustworthy. It's spotty, it's down, it doesn't exist. You still need to be able to take data, you still need to be able to analyze it, you need to be able to do things with it all locally, right? And then, and this is kind of getting into my next point, which is the idea of write local, sync later, right? You can't trust, just like you can't trust servers, you can't trust disks, you can't trust the network, right? Your applications have to be available all the time. So at Cloudant, we call this write local, sync later. We live in an asynchronous world. The local device is always available. It's really fast because it's you have to go over the network, and it's ready to go. You can create a rich offline experience for your users. And then in the background, when the network is good, you can sync the data to the cloud. You can sync the data to your core distributed programs. I think that to get back to your question, like we've talked to contractors, defense contractors, who want to take data on the field, take data on the ground, cell phone data, pictures. They want to use the most important thing is that nothing gets lost, and so it has to collect it constantly. If you're waiting for the network to be able to make your requests, make your sync the data up, you risk the opportunity of vital information, even more of it in terms of defense. But this applies to everything, right? This applies to any sort of mobile application that you're building. Your users are going to be on planes, they're going to be underground, they're going to be in areas where there's no Wi-Fi. Make sure that you give them a chance to always use the application. I personally I can't stand any application that always has to have a connection, right? If they're making requests, over the wide area network for every single interaction, I probably have already deleted it from my phone. So this is a design pattern that we see often with our customers. The vast majority of them have already implemented a mobile solution, and if they haven't, we're telling them. And so that brings me to one of the things that we do for Cloudant is we take a lot of these strategies to heart in the data layer, and we do them for our customers so that they can build them. We allow our users to focus on what they do best, which is building applications, building user interfaces, the things that are going to differentiate them from their competitors. What's not going to differentiate them from their competitors is the database layers, or the access controls, or backup. Right, that gets you a seat at the table. That just is absolutely foundational. And so, in the same way that I would hope that nobody here is, not nobody, but I would hope that most people are turning to infrastructure providers for your server needs, right? turn to another company for your data needs because we're the experts. We know what we're doing, and it allows you to focus on what you do best. So I'm going to go through a couple one example of how these principles come into play in the real world. It happens in one of our bigger customers. It's a company called Hothead Games. They are a gaming company out of Vancouver. They originally started doing console games. If any of you know Penny Arcade, they did the Penny Arcade game for the PC. And then they switched to mobile gaming because they were sick and tired of the 2-year dev cycle, right? The fact that to get a game onto the console took 2 years of development, testing, QA before you could get it out there. They wanted to iterate fast, put games out there, learn from their mistakes, and move quickly. And they found you can do that in the world of mobile gaming and lightweight gaming in general. So they did a lot of things right, but a few of them wrong. Luckily for them, I mean, they're a mobile game company. They had a mobile strategy from day one, and that strategy included offline, local, write local and sync later. They did okay with their application layer. In fact, their application layer was stateless, could expand pretty easily, and they made great use of that. But then they did some things not so well, and one of the things they did not so well was plan for failure. So, getting back to the kind of original point of, we can make that, we can worry about scale when we get there. Well, these guys released a game in the App Store called Big Win Soccer. It got this feature, which they weren't expecting, above the fold, biggest picture on the App Store, right? They got crushed. They got absolutely pounded. Everybody and their mother downloaded the game, and they couldn't take it. They're still working on a single database server. They ran into the data contention issues. They ran into all sorts of issues of scale. And a consequence, they went down hard. This is actually their slide that I sold. Right? This is how they do the world, right? It's like, boom. So, Apple thing happened, and it killed them, right? And this is what happened to their user base, right? February 29th, they get the feature, up and up and up. They crash hard, and they're all gone. And their CTO said to me, they're pretty good. They're really good at developing games. They're really good at UI, at a nice, rich experience. The most expensive thing they do, the hardest thing they do, and the most expensive thing they do is acquire users. Right? It is what costs the most money, bar none. Every user that they acquire that doesn't stick around is money out of their pocket. From here to here, that's a lot of money. And the funny thing is they were up, right? Like they came to us, we helped out, blah blah blah, and they were back up, a week later. They were running fine. The momentum was such, and the experience was such that they had to fight against that. And it took them, months to get back to the user base that it was. It was not catastrophic, but it was close. And this could have been, I won't say easily avoided, but it could have been avoided with more forethought into how things are going to break, when they break, what do we do to fix them, and how to worry about scale up front. So this is what, this is what it looks like. They would get users, they would get overloaded, their database server would fall over, their application would start falling over, and they go down. They'd get it all, it'd work very hard to get it all back up and running. They were trying to scale up their database server, right? Getting bigger and bigger Amazon instances, Quad, XL instances to try and handle the load, and they couldn't do it. They couldn't do it, and that's why they lost all these users. Right. Latencies went through the roof, users left. They left and they didn't come back. They did an analysis afterward where, what were the users that came in and logged in to the game every day and just try and see if it was there? And that number was basically zero, right? You lose a user, you don't know off until the next game comes out. So you can get that one shot. So if you have that one shot, make sure you take it. Make sure you have it. This was a good day. this is what a good day looked like, right? What's nice about their applications, once they got the data under control, they can scale the application tier, what they call their API service, very easily. And they can do so in a diurnal pattern, right? So overnight, things aren't so busy, they can scale down, they can save money, right? During the day, peak hours, they scale out to meet the need, and they're able to handle it all, right? This is, as I said earlier, this is what EC2 was built for. This is what Rackspace Cloud is built for, right? Stateless application servers that elastically scale up and down. It's great. You should use it. You should use it for that sort of thing. So, what else did they learn? Well, they had a team of, 30 some odd brilliant game designers, and they had 3 guys working on the infrastructure. And one of them was the CTO, who, had a couple other things to do with his time, right? So they made the decision that handing over that infrastructure to somebody else, to the experts, would free up more of their developers' time, save them money, allow them to go out and get those users that had gone away, and try and get more users to fill in that void. So they focused on building the things they were good at. They focused on, they allowed us to focus on scale. They focused on scaling the app layer, where they allowed us to focus on scaling the data layer. And that allowed them to build, 4 more big win apps, which have all been pretty successful. They have a war game app called Rivals of War, which last I checked was somewhere in the, it was top 10 in the Apple Store for games. And they recently signed an agreement to release a game with Major League Baseball, licensed with Major League Baseball. Now, I didn't know this, but apparently Major League Baseball is kind of a ball-busting organization, right? They take their brand very seriously, and they impose pretty heavy SLAs, pretty heavy fines, and some pretty heavy penalties if you mess with their brand. Hothead wanted that deal. They needed the confidence that their system wasn't going to fall down, or they were going to pay those penalties. Taking into account a lot of the practices that I hopefully outlined during this talk, they had the confidence to actually go do that, and it's been a big success for them. So that's kind of I think that what happened to them can happen to, I've seen it happen to a lot of apps, it can happen to anybody, and it can be catastrophic. You can come out of it, but you can also not come out of it. What are the old cliches, right? A stitch in time, and an ounce of prevention, and all of those things hold true. Right? Get started and later after, but don't think you can wait until you get to the problem in order to fix it, or you might not have that chance. So that's that's all I had. Sorry, but hold on.
Before we move on to the Q&A, I want to give a great round of applause to Al Hoffman. For those of you who are interested in winning an iPad mini, there is a bowl passing around. Please throw your card in there. We will raffle it off at the end of the QA.
It's thank you so much for having me. I wanted to say, I can get the slide to work. Feel free to email me. It's real easy. It's alan@cloudant.com. You can find me on Twitter. If you come to our IRC channel, if I'm not there, other people are there, and they're happy to talk to you guys. We work with and for developers. We really like people that come in and ask intelligent questions. So again, come check us out.
Okay, first question? Yes.
So, a little bit background. I've been doing a lot of, for years and years, relational database development, SQL development. So it's a real transition ahead of going over to document-based databases. So I'm trying to design an app that can scale, but now, all of a sudden, now your documents could be big, or you could have, which blows my mind, you could have 1 million databases, maybe. What's some of the best practices in terms of, do you have a lot of databases? Do you try and get a lot of different types of documents in a single database? Or just, larger, which is sort of what it gets, larger documents?
So that's a good question. So the question was around some best practices for number of databases, number of documents in the database, size of documents. It's dependent on the application, obviously. One of the patterns that we've seen work really well for mobile users in particular, so is to have one database per user, right? So all of the users, all the users' data lives inside a single database. So with our system and with I want to say most document stores out there, I wouldn't say all of them, I'm not quite sure. The level of a transaction, the atomic level of transactions of documents, right? So that's what you want to work with if you're, I want to dispel the myth that these things aren't there's no transactions, right? Because there are, you just have to move in some document. But the security level usually applies at the database, right? So if you have many millions of users, you want to make sure that all of their data is locked in one place where only they can get to it. I mean, in reality, you can do this using views, using indices, using access control. But another way to do it would be a pattern of one database per user. We've seen that work pretty well. You have to be careful about like super users. You have a database of databases, right? A database with all the records for each individual, so you can keep track of who has access to each one. But that's worked really well for kind of consumer grade mobile apps. Does that make sense?
In terms of should you mix different types of documents in a single database? Or
as long as you're smart about your indices, that's not a problem, right? Because you can do filter, you can build your MapReduce functions that you're going to throw out. You can throw out 99% of the data and only index the ones of a certain type. You can do, when you're doing replication between, say, the cloud and the phone, or between two different sites, you can do filtered replication based on properties within the document. So mixing data, quote-unquote data types within a database is not that big of a deal, unless, for kind of cleanliness sake and you don't want it. But it's really not.
So when you remove a document from the index, the whole tree structure, you really rebuild the indexes that time?
No, that's one of the nice things about it. So the question was, when you remove a document from the database, do you have to rebuild the index? And this is kind of one of the differences between what I call like capital M MapReduce that came out of Google and scattered data algorithms that go under the name MapReduce. Right? So with our system, the indices are incrementally updated, right? So you only care about the delta. You put in 10 documents, those are going to be updated, and almost inherently, because MapReduce is an algorithm that takes a single document and that's the level of operation, you don't have to worry about joining, you don't have to worry about taking data from one and doing something to the other, right? You don't have to worry about cross-document properties. So it allows you to just focus on the delta and the change in data. You remove a document, it gets removed from the index, that index is updated very quickly. You call it soft real time, right? Because you can update it.
Since you're moving the relative indexes for the other documents, that's going to update automatically. Right?
So in terms of, so if you're talking about like ranking, right? Ranking algorithms, so that's an extra step. That is going to take, I mean, I wish Adam was here to be a little more specific, because he actually built the system that does chain MapReduce and can actually update. There's a history associated with each of the indices, right? There's you'd be much better at this than I am. But you can tell where it came. You can tell where you can follow the lineage from document to first pass to second pass to end result, and you can actually update the end result in an incremental fashion. You don't have to rebuild it. All the other properties will change, but it's not like you have to scan through all the data to make those changes. Does that make sense?
Next question.
Hadoop style MapReduce is batch processing, right? Which is
Alan will be here for one-on-ones. I just wanted to give other people a chance to put a question. You have your hand up?
Yeah, just curious how you went about choosing makers to go with Couch instead of the other NoSQL.
Sure. The question was, how do we choose Couch? So Couch is, I hope is one of the core pillars of our technology. We were familiar with CouchDB from our physics days. We actually used it Brookhaven National Lab, used it at the LHC, used it at CERN, mostly for bookkeeping, for data provenance, right? Which data came from, which run, and which people have touched that piece of data and, done something to it. So it turns out to be a fantastic data store for that. Just that, that application really fits it well. So we're really familiar with it. And so that obviously biased us. But there were two things that we really liked about it that we thought, we had this idea of building a scalable data layer. So what CouchDB had that we couldn't find anywhere else was the append-only B-tree structure of the data underneath. With multi-version concurrency control, right? You don't ever overwrite data. You only write to the end and then compact the old data away, right? So it's almost ungood. It follows the principle of planning for failure because you don't have to worry about corrupting your data. Mid-write, somebody comes in and access the database, they get a snapshot, and they deal only with that snapshot, right? Other people can be doing other things to the data. Doesn't matter, right? Data can, that feature gave us confidence to run it in a distributed fashion in an untrusted environment, like the cloud. And the second one, which is almost completely on the other end of the spectrum, was the interface. Right? They had done RESTful service perfect. Right? We couldn't find that in any other core technology, and we were so bullish. We're so bullish on JSON and HTTP and REST as the way to access data, the standard, that we want to just take their API and import it into our product.
Next question. Yes. Right there.
Actually, you have a picture, the diagram of that the mobile strategy, the mobile device, desktop, and cloud. And why the mobile device not talk to talk to the cloud directly, have to talk to the desktop?
More or less for aesthetic purposes. It just looks nicer. No, obviously, most of our customers don't actually have a desktop client version of their software. It's just cloud, and they're talking directly to
So what kind of framework inside, embedded system?
So there's a couple different you can use. The one that we recommend, so in full disclosure, we have our own that's coming out. It's not fully baked yet, but a cloud mobile that's literally an on-device, a library that you'll bundle with your app and knows how to speak with SQLite as the data layer. But there's a great open source project out there called TouchDB, which a lot of...
That one I saw is already bad.
What?
I saw that one's bad already.
I think the rumors of its demise have been much ballyhooed. There's a lot of developers working on that project, including people at Cloudant. But that's one for both iOS and Android, that it knows how to translate data from SQLite, the native data format, to something that speaks the cloud replication protocol.
So which one you recommend?
That would be the one I'd recommend, yeah.
How about Pouch? PouchDB?
PouchDB for in-browser stuff? I think it's a good project. I don't think it's as far along. I don't think it's as baked.
It works with iOS and BlackBerry.
Oh, it's the BlackBerry is a good call. I don't think there's a TouchDB version.
Okay, we have time for one more question. You got one, right?
Anyone else?
Anybody else? All right, it's yours.
Okay. I know it's big data, but in developing an app, I'm very concerned about growing really big, really fast with a small number of users where the income's maybe not supporting it. So, for example, when you're taking a document, and I just need to change one number, and then write it back, and it's a new version, and it's replicated 3 times around the world, do I have to be concerned about that, or are you doing some sort of optimization to not always save all of that data 50 times?
So that's a good question. The question about kind of access patterns for a lot of data with a few users. You don't have to worry about the multiple copies because you're not. It's not like you're. We use a quorum system, which is similar to the original DynamoDB paper, right? So there's 3 copies of the data. You have to write successfully to 2 of them to make it. 2 of them have to write successfully in order for it to consider it a success, and you have to read 2 of them that are the same to have a read. So it gives you something called read your writes consistency. You basically can't write a piece of data and then get back a different piece of data, right? We allow for kind of partial updates and stuff like that. Not partial updates within a document, but like if one write succeeds, we'll give you a different error code that says, we've written it once, it's going to be replicated around the cluster, but if you read it back, it's possible to get non-updated data. In terms of like changing one little piece of data within a document, I will say that that's one of the drawbacks to a CouchDB-based database system. We don't do update in place, right? We said the risk of corrupting data is too important for us to allow for people to kind of update data, at the bit level on disk, right? You get a snapshot, you write to the end, later we compact away the old stuff. And that's just a design trade-off.
Okay, before we go on to the iPad mini raffle, I'd like to give a great big round of applause. Alan Hoffman, everybody had a chance to put their card or information in to win the iPad mini.
Quick question, are these
You got about 40 seconds to do it.
available?
I'll work with, we'll figure it out. I would like to make them available, yeah.
Would you mind kindly closing your eyes and reading again? Read it out loud.
Alistair McKenna.